On diversification. You know, the study of statistics has sometimes been called sadistics, and I'm going to try and change that. You know, there's the idea of diversifying. Don't put your eggs in one basket. Here we have a series of a bunch of random securities, and we take the average of them, they seem to have less risk. And it's generally argued that people prefer less risk, but why? Well, it turns out that people usually dislike losing more than they like winning. So one way to approach that is minimize the risk. And while that's generally true, it should not be always true. A note that just as many people sleep at night, aren't we glad that some stay awake? That some men stay with the women. That some people actually are risk takers instead of risk averters. They find the magical rewards. Now, a guy named Markowitz in 52 looked at the mathematics of all this, and if you had a graphic, you would see that it bends to the left, and more so the negative correlation, where you have return going up, which is what we want, and risk standard deviation on the horizontal, where we want to go to the left. And we can look at a two case, and turns out a mnemonic might be to think of tiles. And if you had two cases, that'd be 4 tiles. The 2 corner tiles are squared, and you have 2 other tiles which are adjacent to both, so there's 2 of them. Let's do a 2-case example. Say we got GM and Procter & Gamble, $8,000 in GM, $4,000 in Procter & Gamble. First we got to do is figure out the weights. That's the fraction of the total computed by the dollar amounts in each over the total dollar. So that's 2/3 in GM, 1/3 in Procter & Gamble, and we can figure out the returns easily by taking the weighted average, and we can even confirm that amount if we had done it the accounting way, and sure enough the total divided by the investment portfolio total is also 8%. For the portfolio risk, notice we're doing the variance. We'll take the standard deviation later. It's the squared weights of the squared standard deviations. That's a variance. And again, 2 times the 2 weights and the correlation times the 2 standard deviations. Well, if the correlation is 1, we'd square the weights and square the standard deviations and take 2 times the cross product of both and the standard deviations times the correlation. And in the case of 1, we'd get 9. If 0, a little over 8. If -1, only 7. But we could flip the weights. How? Selling $4,000 in GM and then buying $4,000 of P&G. In that case, our results would have been, well, 6, square root of 20, which is about 4.7 or so, and square root of 4 is 2. But we're not going to have just 2 securities. No, let's generalize this. And it turns out it's a square matrix, which means if I had 5 securities, I have 25 computations, or n squared. Now, what's interesting is look on the diagonal. That's I equals j, and that special case turns out to be a variance, and we can make a substitution. Notice there are n of those, n squared minus n of the covariances, and now let's create what's called a naive diversified portfolio. How? Just put 1/nth as the weight in each. Then look what happens as n gets big. The idiosyncratic company variances approach 0. The remaining covariances, the market if you will, become an average. And you know what? That means you can avoid the news about specific businesses, but wait, there's more. Let's now take all the risky assets in the world, create something we're going to call the feasible set. We can show it's kind of smooth, continuous to the left. We'd want to be up and to the left, perhaps on what they call the efficient frontier. And then, yes, we're going to add more, called the capital market line, and that's the risk-free, if you will, treasury bills. And when you do that, look what happens. It's a straight line. It's a tangency. We think that's the market. And everybody would move up and to the left and not pick stocks, because those are down below inside the feasible set with Dr. C Invests.